and may or may not still be some broadcasting stuff over at the UCSD site. There certainly is over at the Channel 10 site, but 8 is the star attraction.
Yeah, right now. Yeah.
All right, we should be.
May or may not still be.
We should be live here now.
Some broadcasting stuff over at the UCSD site.
Sorry, I've got an echo going on.
Channel 10 site, but 8 is the star attraction.
Yeah, right now. Yeah.
All right, we should. Okay, there we go. Welcome everybody to the September meeting of Palomar Amateur Radio Club. I am Joe, K6JPE, president. We will get things started with the Pledge of Allegiance. I'll get a flag up here for us. Maybe, there we go. All right, if you're wearing a cover, please remove it. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
For all. Nice
Thank you all.
Nice display of belly buttons.
Thank you all and good evening. As has been the tradition lately, we are continuing with virtual meetings for the purpose of keeping everyone safe in the time that we are living in right now. We hope to get back to in-person stuff and some more sense of normalcy soon. We do have the picnic coming up at the end of this month, and that is going to be outdoors at San Dieguito County Park, Area 4, as usual. At this point, we do plan on having that. We are also still planning on the auction to be in person at the October meeting at the auditorium in Carlsbad. That's not the community center, not the new building. It's the auditorium where we normally have the auction. So that is the plan. We will be confirming that with the board at the board meeting next Wednesday night. And if we come up with something different, we'll be sending out a lot of emails and, try to get a hold of people to let you know if we're going to go virtual like we did last year. All right, on to the agenda. Visitors. I see a whole bunch of people that I have not seen before. Hey, Paul, welcome. KE8NN.
Mm-hmm.
I'll let you introduce yourself. Tell us where you're from and what brought you here.
Yeah, Paul Gunderson from Cleveland, Ohio. I've been living in California for off and on for 2 years. I finally got my California driver's license, and I changed my FCC mailing address about 1 year and 3 months ago. Hobbies are a little bit of contesting and the work bands. That's where I concentrate my efforts. And once again, Paul Gunderson, KE8NN from Cleveland.
Great. Where are you when you're in California?
Mira Mesa.
Okay, fantastic.
Yeah, we spend 10 months of the year here, 2 months of the year back in Cleveland.
Okay, well, welcome. Glad to have you here.
Good to be here.
Some other faces I don't recognize. Rob, are you KI6JSV? Have you been here before?
Yeah, I've been a lurker probably three meetings over the past year, and
okay.
That's okay. And my membership didn't auto renewal, so I re-signed up today, and then that prompted me to join you again tonight. So
okay, well, great, welcome.
Yeah. And I run a net on one of the repeaters on Sunday nights, so I want to support the club for that opportunity. Thank you.
Fantastic. Who else is the first time? Might be easier if you just raise your hand and I'll pick you out and call on you. Paul, yes, N6CON.
Yep, the other Paul from New York. Hey, moved out here back in November. This is the first time I've actually joined. I joined the club way back in the fall, but or actually in the spring, I should say that. Ed Sampson and Bill Calderwood were kind of like mentoring me and got me involved back again in ham radio. It's been a while. So I'm spending most of my time supporting the Coast Guard Auxiliary and their radio operation. But I wanted to.
Hey, I just got my Coast Guard Auxiliary renewal notice that I need
Awesome.
to pay them my money.
Yes.
So are you a 106?
No, I'm a 105.
Oh, okay.
So yeah, we're in the same division, but it's different flotilla.
Okay.
But it's really nice to join all of you tonight. I hemmed and hawed whether I should be a lurker or a joiner, and I said, well, I'm going to be a joiner rather than a lurker, and I'm glad I did so. It was nice to hear from Ron and his experiences back east as well. So very nice to join all of you tonight. Thank you.
Great. Glad to have you. All right. Anybody else? Okay. How about normally we ask brand new hams. I think everybody here has been a ham for a while. How about license upgrades? Anybody recently tick their upgrade boxes? No? Okay. Okay. Announcements. I covered the plans a few minutes ago for the auction and for the picnic. So looking forward to that. And that brings us to committee reports. I still don't see Mark. So John, do you happen to have any info on technical for us, or are you pretty much out of the loop on that?
No, we went up a couple of weeks ago on the weekend and picked up a 80-foot nominal tower, very, very heavy tower. And Mark managed to drag it, hauling, huffing and puffing and all of that sort of thing. And we got it over to our site. So we have some future applications for a HF remote station with the HF radio actually located on our site. And we have a problem. We've had a problem ongoing for a long time with the 6-meter radio, and Mark wanted to upgrade it more properly than me throwing one of my 3-dimensional kludge boards together for an interface. So Mark and Glenn and myself designed up a more modern circuit with better protections and things like that. And hopefully in another month or so, we'll have the 6-meter radio back on the air. But we have a little interface board that's required to make a conversion to get the 6-meter audio and the 6-meter push-to-talk signals, the correct polarity. And that's as much as I know at the moment. Mark did come over to my house, and he picked up the Yaesu 757 and a couple of other boxes of odds and ends, and put them in proper in storage over at the club storage container, because I basically am running out of room at my house. So he thought that he could store them more properly at the club container in Escondido. And that's as good as I know.
Okay, great. Thanks, John. Glenn, do you have anything to add to? I know you've been involved in some technical stuff, and then once you're done with that, you can go right into your membership.
Okay, well, I'll say actually, John and Mark have done all the work on the interface, not me. John did one up, a diagram and such, and Mark looked it over and said, well, let's change this, and let's do that, and let's do this other thing, and let's make a real circuit board and all that. So that was out of that. Yeah, I'm glad the tower got pulled up and moved over there. And I think that's all the techie stuff I've got. So I'll move into membership. So today I sat down finally and I did 14 updates of the database for members having made payments and such. And so we are now back up to 154 members. And I think that's all I've got. If anyone has any thoughts about membership or getting people more engaged in the club, the board would love to hear them. I'd love to hear them. Thanks.
All right. Thanks, Glenn. There's Mark. Welcome, Mark. Thanks for joining. We just actually finished our chair reports. John talked about the tower and some equipment you picked up to store, and I think that was the gist of technical, unless you had anything that you wanted to add. Wires X, maybe? Hint, hint.
I completely rebuilt the Wires X, and I'm getting ready to test it again. And I completed the schematic for the 6-meter repeater interface, and then went over to John's and found out that we have a huge amount of CTCSS tone. So Glenn and I are both designing high pass filters to get rid of the CTCSS tone. And we'll, oh my, it's really dark in here. And we'll run simulated filters shortly.
Okay.
In case, and just FYI, I've been out running around all day. So the car had 2% energy left in the electric car. So I just pulled into the supercharger, and I'm running this off of a Wi-Fi hotspot and an Android tablet. Hi all.
So that's the equivalent of running on fumes. Is that, what do you call it when you're running on fumes on the Tesla?
Yeah, I guess it's just running on electrons. There's only a few left.
Just a few electrons left. Yeah.
Yeah, you could count them going out one at a time.
That's referred to as being a pedestrian.
Yes.
That's why his picture is so dark.
Yeah. There isn't enough power to turn the lights on.
Yep. Yeah. If you turn the dome light on, you might lose everything. All right. Okay. Well, thanks for that, Mark.
Turn on the dome lights.
Oh, there you go. Well, it's kind of behind you, so that doesn't really help.
Behind me.
It's funny you mentioned dome lights, because just last night we figured out on my wife's car, which we've had for 3 months, how to turn the dome light on.
You ready for this?
I bet it's not voice activated.
Yeah.
No, it's just a very complicated car.
Set the dome lights to auto.
Couldn't set it to anything. We couldn't figure it out.
No, he was telling his car.
Oh,
Well, it's easier than going through the 12 levels of menu to get it done. Anyway, let's see. If we already talked about the tower, it is there. Charlie is working on the legal part of it. I got a beautiful Yaesu. I don't remember the part number. A few-year-old Yaesu HF rig, power supply, the whole bit, desktop mic, gorgeous system that now belongs to the club. So we'll
That's a
figure that out.
757.
757. Thank you, John.
yeah, that's a nice rig. I had one years ago, but the thing's probably 40 years old.
Anyway, let's see. We did the 6-meter. We did rebuilt Wires X. Think I may have figured out what went wrong. I hope. Keep your fingers crossed, all. That's pretty, and it's very dark where I am.
All right. Good. Well, thanks for that. Okay. Any other questions, comments, announcements for the group?
By the way,
Now's
for
the time.
all of you people who understand power, I'm currently drawing 136 kilowatts.
Currently.
Currently drawing 136 kilowatts out of the mains.
Nice.
I just have one thing, if that's all right.
Sure. Go ahead, Jim.
Yeah, the phone up on the mountain has been disconnected as of today. That account is basically done because we've got the internet access now. So
Yeah, that's great. I saw that email. Thanks for that, Jim.
yeah, I'll save about $38 a month or so. So that's pretty good.
Which we'll then give to the internet provider. But
Yeah.
you know,
Yeah.
it's
Well-
if they ever bill us.
Yeah, I was going to say, because the owner came up and put that system in himself, and it wasn't a regular install. We haven't appeared to have made it to the billing system yet. And I reminded him once, so I feel justified. I did my part.
Yeah. Yeah, that's kind of like we bought an RV and the satellite radio was still active, and the previous owner owns a company with a fleet of trucks, and he added the satellite radio for his RV onto the fleet. I reminded him like 6 times over the course of 9 or 10 months to turn off the satellite radio so that we could put it on our own account, and he kept saying okay, 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 and then I just gave up. It's been 3 years. I did my part. I don't feel bad. So
Yeah, I don't feel bad.
If you ever sell it, take that radio with you.
yeah, if only it's a built-in, but yeah. All right.
I have an announcement.
Oh, yes. Go ahead, Joe.
Oh, we are back to in-person testing. We had our second or third time last month. One person from the month before got his general, and then I think 6 others got technicians. So our next session will be September the 25th, the day of the picnic.
Of course it will.
Yeah.
Actually, that reminds me. Thanks for that reminder, Joe. And that's always great to hear about testing sessions and opportunities. Jay Goldberg had their first back to in-person class for technician last month at my church at Pacific Beach United Methodist in Pacific Beach in San Diego. And that class was 100% pass after 1 retake. And I think there were 13 students in attendance. So 12 passed the first time, 1 retake, and passed the second time. So that was a pretty good session for being the first one back in person. And we have another one coming up on October 2nd. So just a month from now is going to be another one at Pacific Beach United Methodist Church. San Diego ham classes. Look it up on the internet and contact Jay Goldberg for more information on that. If you have any friends or family members who want to get their ham license, it's pretty crazy, the pass rate for doing that. If you have any technical skill or knowledge whatsoever, just getting through that class where they review all of the questions and answers, and then you sit down for the test right then. So that is October 2nd. And all right. If there are no more announcements or questions or comments, we will introduce your board. We have KF6WTN, Mark, your repeater site and tech chair, who you heard from, is waving at us from the darkness.
No,
Pete?
I just remembered the sun visors have a vanity light in them.
But you're still waving at us from the darkness because it's all darkness around you.
Well, behind me, it sure is.
Yeah. Your scope editor is Keith, KM6CXW. Directors Chris, KD9LF, and Ron, AJ6FQ. Glenn is your membership chair, AI6RR, who you heard from. Jim is one of the Jims is your treasurer, K2VO. The other Jim is your secretary, W6TQS. Charlie is your vice president, NN3V, who I do not see. And I am Joe, K6JPE, your president. And I will now turn it over to Steve, KA6UGS, who is visiting us from Coachella Valley, Palm Springs area, presenting about the new FCC rules around RF exposure. So welcome, Steve. Thank you for being here, and take it away. The floor is yours.
Okay. Thank you very much, Joe. It's a real pleasure to be here. And I mentioned earlier during the kind of opening moments of the Zoom meeting, and I recently moved to cathedral city near Palm Springs from, I lived for about 20 years in Kensington in the San Diego area. So I have a real fondness for San Diego and count as having still many friends in the area. So I'm hoping that you will interact with me during this presentation. That helps me a lot if you ask questions as we go along. And the one apology I'm going to make early on is sometimes manipulating Zoom, if you don't do it often, is a little challenging. So I'm hoping I can get everything right as I do this. So the first thing I'm going to do is I'm going to share screen, and I'm hoping that you are going to see a screen at this point which says Amateur Radio FCC Human Exposure Rules Update.
Cool.
This was a rule that was a long time in the making, and it was published in April of this year. It took effect for new stations in May of this year, but there's actually a 2-year rollout in terms of existing stations complying. We'll get more into that. I got tuned into this by a Rat Pack Zoom presentation that Greg made on what was happening, and I became aware of all the hard work that Greg has been doing as the chairman of the ARRL RF Safety Committee on behalf of amateur radio. And so a lot of the material in this presentation came out of his presentation. I also want to make a point that this is not an attempt to be everything you need to know about RF hazard at all. It's more about what you need to know to comply with the new FCC rules. And the ARRL has a really good website. And by the way, the very last slide, I'll go over all the links that I refer to this in this presentation. So you don't have to copy this one down, but they have a lot of information available. It's pretty customary for any presenter to take one slide and tell a little bit about oneself. I got my license back in 1966. I was in the Chicago area. Some of you will recognize the Drake 2A receiver, couldn't afford a 2B. So I had a 2A and the T60 night kit transmitter and the little inexpensive Helicrafters receiver. I don't remember what that 10-meter AM radio was, but that was my station back when I first got my license as a freshman in high school. On the right is my experience with high-powered AM transmitters. I like this picture because it points out the triode that I'm holding there. It was developed by RCA, and it was used as an induction heater during World War II. And then both RCA and Westinghouse, and this was a Westinghouse transmitter, used it as both, 2 of them as the power amplifier and 2 of them as the modulator in a 50 kilowatt transmitter. This was at WOWO in Fort Wayne. And even though we didn't run the heaters at 11 volts, so they didn't consume 285 amps, we still ran them at like 9 volts. So there was a lot of current on the heater and the plates. We didn't run the plates at 10.2 kV, but we probably ran them about 9 kV. So this is a picture for people that love vacuum tubes. And this is a pretty big vacuum tube. And also, it's a commentary of what happens to one's hair over the years, I think. So why does the FCC regulate RF hazard? It came out, I think, of concern for the proliferation of transmitters and RF devices post-World War II in our country. So it was an offshoot of the 1969 National Environmental Policy Act. And the FCC's done a really good job on this, I think. Along the way, in the mid-1980s, they issued this Bulletin 65, which has become the standard of information for RF hazard. And they even did a supplement B for amateur radio, which specifically talked about how RF hazard should be dealt with amateur radio operators. So what's the advantage for amateurs? Well, at one point I was the chief engineer of one of the TV stations on Sutro Tower in San Francisco. And of course, Sutro Tower is a 1,000-foot tower in the middle of San Francisco, a very dense population. And the neighbors and special interest groups basically decided that the tower was causing childhood cancer. And there was quite an environmental study done and a lot of research done. In the end, the incidence of cancer in childhood in the vicinity of the tower, which is at the intersection of the vertical and horizontal axis, was really no greater than anywhere else in San Francisco. But by the TV stations and the facility adhering to a standard that had been established for a long time. Matter of fact, the standards were established in the 1980s, and they have remained unchanged since the 1980s. By adhering to that standard, they were able to say to the community, listen, we're really sorry about this, but we're operating within standards that have been proven by the IEEE and other scientific organizations to allow us to operate below any sort of RF level, which might be detrimental to human health. So I think if by knowing what your RF emissions are, if you were in a situation where a neighbor would knock on the door and say, listen, I think that so-and-so sick because of your amateur radio transmitter, you can say that you're sorry about the health issue, but you're operating within standards that have been proven to be very, very effective and useful for protecting human safety. So there was an evolution in the FCC rules, and when broadcasters, and I was a broadcaster in 1986 when we started having to comply, and other services that the FCC regulates, they had to comply, but it wasn't until 1998 when the FCC required all stations, all transmitters to be evaluated for compliance within their exposure guidelines. And what happened in April of this year was the FCC saw that some of the categorical exclusions to evaluation, one of which amateurs had, but other services like land mobile, for instance, had, they weren't really working out because sometimes an 80-foot tower could be built 25 feet away from a building with a 900-watt transmitter, and guess what? People in that building were being exposed to RF beyond the limits, and so they decided they couldn't do these categorical exclusions because basically they just weren't providing protection to the public. What they did is, for amateurs, they created exemptions that to the routine evaluation that everyone has to do on the transmitting system. The other thing was mobile transmitters and handheld transmitters were formerly excluded. Now they are not. And in the case of devices that are 20 centimeters and closer to the human body, the actual evaluation has to be done through the specific absorption rate testing or modeling, which isn't something amateurs can do. We're going to be depending on the manufacturers to do that. And we'll talk more about that in a couple of future slides. The one point I want to make is the emission levels, the limits haven't changed since the 1980s, basically. So the emission limits that were originally established held to be effective and useful and remain unchanged. So this is what's no longer valid. These were the exclusions that are related. If you had an 80-meter antenna and you did not have any more than 500 watts at the input of that antenna, you were excluded from having to do any evaluation. So you can see that unless you were running a linear, high-powered linear, basically nobody had to do really much of anything. And of course, mobile and portable devices were excluded. What's happened is that exclusion has been replaced with what we call this exemption. Basically, if you are, and the formula is wavelength divided by 2 pi. So if you're at 3.5 megahertz, basically from this chart, you can see if you're 41.3 feet away from any part of the antenna, you're excluded from having to do an RF evaluation. Now, there's another part to this that I want to point out, but the first thing is, if you're at these distances from your antenna, you're basically excluded from doing an evaluation.
So there's not a power number associated with that anymore.
That's a part 2.
Okay.
Thank you. Part 2, what's the maximum power you can run? Well, I don't know how many folks online are familiar with ERP, effective radiated power, but basically effective radiated power is your transmitter power minus any coaxial loss, transmission line loss, plus the antenna gain, if you do it in dB. So an example is a 30 watts ERP comes out of a 40 watt VHF radio with 75 feet of RG8X and a ground plane antenna. So that's ERP. And there are ERP calculators out there that you can use. Once again, I'll have these listed at the end to determine what your ERP. So the FCC has said basically, and it's really all the amateur bands until you get to 6 meters. To calculate what your maximum ERP is, it's 3450 times the distance from the antenna squared divided by the frequency. Now,
well, what do you do with a sloper?
Well, it turns out any part of the antenna, but we're going to talk more about it. One thing I want to say is do not have any anxiety about any of this, because remember, this is for the exemption to do any any RF assessment, but there are easy tools in which to do RF assessments for that. So,
okay. I had a quick question.
Yes, sir.
Yeah, you were talking about just kind of like the limits, and like if we're operating within the standards, really like we're kind of like okay, and maybe you kind of alluded to like it doesn't cause cancer. But I guess like, you know, I guess my question is like, even though we're operating within a particular standard, it probably is possible it could expose people to cancer causing like RF or tissue heating. Have you come across like any studies where it does cause cancer? Because I think you were saying that it looked like there was like, you know, uniform distribution from that tower in San Francisco and all the surrounding areas. But like, do you have any more data or research on maybe operating within the limits, but still being a problem health-wise?
Well, to be honest with you, back in the 80s, there was a lot of discussion about the limits. And the people that had transmitters felt the limits that the FCC had established were far too low. And the proponents for health felt like the limits the FCC had established were far too high. But in the, almost 40 some years, the original studies done by the IEEE and other scientists pretty well have proven out. You know, the issue is, as you said, the heating of the tissue. That's the issue. And you know, to be honest with you, when we get into a little later phase of this, you'll see that the categorical extensions are so conservative. If you actually do an RF evaluation, you'll see you're at a minuscule part of what the FCC limit really is. So I understand your concern but I gotta say that, you know, I started in radio broadcasting 53 years ago, and I just retired at the end of June of this year. And in those 53 years, I have not seen any information which really indicates there's human hazard at the RF levels associated with particularly amateur radio stations.
Hey, Steve, it's Paul Cutters, if I may. I just want to kind of break in and say, has anybody paid any attention to the Aries newsletters or the email flying around over the last 2 weeks about lawsuits over a insulin pump that has been lodged against a ham radio operator, where they're claiming that the actual radio signal has been interfering with the insulin pump. So that's something to be aware of. I'm not saying it's true. I'm not taking sides on this, but it was something that was circulated on the Aries Aries IO news feed, and it's something that is still kicking around at this point.
Yeah, that's been in the news a lot lately, and it's still underway. As someone who's been doing Part 15 testing on medical equipment for years now, we need to see how that plays out. But I think that the most important thing is to let him finish this presentation. Me having responsibility for all the repeaters, I am extremely interested in your being able to get through this. And after we're done, we can talk about insulin pumps being interfered with by HF rigs.
Good questions. So, but I think I'll keep plowing on because that's really beyond the scope of my presentation. So,
we'll talk about it afterward. That's an interesting problem.
Yeah. I want to say that I basically want to say that, so we left the exclusion world, the world of the exclusions where basically most of us had to do nothing. And now we're entering the world of us having to do a little something. And essentially the RF evaluation that the FCC requires for every transmitter now needs to be performed if a person is within that, what is it, two wavelength divided by pi or whatever distance, and theoretically the maximum amount of power allowed is determined by these formulas depending on the frequency you're in. And just to review quickly, effective radiated power, you can determine it two ways. You can do it with dB by transmitter power minus coaxial loss plus antenna gain, or you can do it numerically, transmitter power times coax efficiency times the antenna gain, basically. So and by the way, kb5r.com has a wonderful calculator for doing all of this. So
now, is that antenna power gain relative to a dipole or isotropic?
Is power gain power gain is always relative to a dipole, but as you say, gain is relative to isotropic. So absolutely. So as much as everybody hates to do calculation, I went ahead and did an online calculator for the exemption, basically. And once again, there'll be a link to this that you can get to this to use. I also want to say that in the grayed out section to the right is the ARRL RF exposure calculator, which is what you do if your exemption doesn't work out for you. But so the trick here for me is I need to minimize the power point. Let me see if I can do this. And I think the way I'm going to go back on this. I think the way I have to do this is get back to full screen here on my, let's see how I get to this. Just hang with me, I'm sorry. I'm going to end my PowerPoint. can minimize it. I'm in my PowerPoint here, so let me. Okay. And I'm going to go ahead and go to this exposure calculator. And I think everybody can still see this, I hope. And I'm hoping somebody will give me a station to use for this. Somebody want to volunteer their station and we'll do this calculation?
Sure, I will.
Well, I've got one for you.
Okay.
I'm not sure about the length of the coax,
Give me.
but John and I.
Give me a call sign. This
W6NWG. Nothing works good.
And this is information to help you. And why don't you give me an antenna name so you know, because a lot of stations, a lot of people have multiple antennas. So you want to name this antenna.
Yeah, this is let's do 14673. So it's a 4-bay.
It's the 4-bay. Okay. And what's the frequency? What frequency?
146.730 megahertz.
7.3, 7.34, did you say 7.3?
7.3.
Yeah, you're close enough.
Okay.
That's exactly right.
Okay. So according to this, you have to be 1.1 feet away from that antenna at that frequency.
Now,
So
how do you know that if you don't know the power or the coax?
Well, doesn't matter.
The power of the coax is there.
But remember the first calculation, it's frequency divided by 2 pi. That is
Okay.
essentially that is the distance you have to be away to be out of the first half wavelength from the antenna. Okay, so that there's 2 parts here. What's the minimum distance? 1.1 feet. What is your distance to the antenna? Human exposure, any human exposure to the antenna?
It's probably a good 40, 50 feet.
Well,
nobody should be on the property except for us.
Well, you count. What's the minimum distance from anybody on the property to the antenna?
Ever?
Yeah.
Well, it's operating.
Well, when it's operating,
Isn't
the
it about
worst case.
45 feet off the ground?
Yeah, I was going to say it's about 40 feet up.
Okay, so let's say 40 feet. Okay. So this tells you.
And, being a 4-bay, it's a collinear, right? So the energy is radiated pretty much straight out 40 feet up.
That's true, but the FCC doesn't care for the exemption. FCC doesn't care for the exemption.
Okay, when I was associated with this, it was exposure over time.
Exemption doesn't matter. It does with the FCC. It does with the ARRL calculator. Doesn't matter with the exemption. So let's just keep going with the exemption, okay?
Hey, it's great to learn new things. Thank you.
Yeah. Okay. Well, this is new rules, but
yeah,
anyway,
this is terrific.
So what's your coax? Those are your choices.
Andrews, what is it, John? It's Andrews 5/8 heliax.
Yeah, it's a half-inch heliax, but it's much like an LMR 400.
There you go. Okay. And what's the length?
You're probably pretty good there.
Okay. And transmitter power?
About
we're running
20 watts.
How much?
20.
20. Okay.
Yeah, it's actually a Yaesu FTM 400 running at medium power.
Okay. So it's a 4-bay half-wave spaced or full-wave spaced antenna?
John, what is it? Help me out.
I'm going to make a guess and say 8 dB gain.
8 dBi or 8 dB?
8 DBD, 4 bay. So you got 1 dipole, 2 dipoles, 4 dipoles.
Well, 4 dipole single pole antenna would have a 4 dBd gain.
Yeah, except that it's only radiating half the pattern.
Oh, so it's directional. Okay.
Yeah.
Yeah, it's highly directional.
Okay. So 8 dBd.
Well, highly being about 180 degrees. There's no reflectors on it. So just double it.
Okay. So here you got it. The calculated ERP is 97. And at that distance of human exposure, you're allowed 570 watts ERP.
So you're not close.
No, you're not even close.
Good.
Good. And as a matter of fact,
you really don't want to screw with the repeaters. So
as a matter of fact, if we run this with the ARRL exposure calculator, we're not even close. So, like I said, these formulas the FCC provided are extremely conservative. So,
hey Steve, if you take a look at that 97 watts effective radiated power, like what would be like the equivalent of that power level? Like I'm trying to get a good handle on that. I've been up this repeater with Mark and John and the whole crew, and I felt kind of sketched out. Got this big ass antenna a couple feet away from me. So even though you're showing me the number here, I just think personally it's just a little bit uncomfortable with all that in my mind, that radiated power next to me. But go ahead.
Is it a couple of feet away from you? I thought.
Well, I mean, I'm still like close. I mean, I'm there in the area, but
the signal decreases at the square of the distance.
Okay.
So
that and one of the other things to remember, even though it's not accounted for in these calculations, is when you start stacking dipoles to create a collinear, you're taking that donut and flattening it out if you look at the antenna pattern. And by the time you get 4 of those dipoles stacked on top of each other, there's not a whole lot of energy coming down anymore. It's all going out. So Hank, when you're standing underneath that thing, and one of these days, if you're curious, I have field meters, RF field meters that we can take up there and play with.
Yeah.
But I had always, due to, just background, I'd always felt that it was never an issue. And now I've got someone even more knowledgeable than I am proving it.
Well, I'm just taking the FCC stuff and
Steve, I have a question also.
Oh, you've got a lot more background than I have, so I'm enjoying this.
Go ahead. So what's the question?
Steve, I have a question as well. When it talks about distance from the antenna, I have, for example, a 102-foot dipole. What part of the antenna are you measuring? The closest?
For the exemption, any part of the antenna.
So the closest part to people.
Yeah, for the exemption. So, but I don't want anybody to get any heartburn about any of this because how about somebody who's got a 160 meter antenna or system or an 80 meter antenna system? Let's put one of those in. Those tougher.
Yeah, so Steve, real quick, on this one, the ERP watts, like Mark mentioned, he has a meter, a field strength meter. So we could definitely take a measurement and it should sort of correlate with this number, right? It should be around there roughly.
No, not really. It's tough to do that. So let me just talk about this for a second. So an isotropic antenna is an antenna that radiates equally in all directions. And so an isotropic antenna has a gain of 1 dB. But a dipole is not an isotropic antenna, it's directional. So a dipole has a gain of 2.15 dB or 0 dBd. Okay? So what this is saying is if you took a half-wave dipole and put 97 watts into it, that's what this is. Or you can put 20 watts, less some transmission line loss, and 4 dipoles stacked on top of each other, because they directionalize the antenna, as Mark was talking about, and they tend to push the antenna, the signal out. It's very, very difficult to correlate received signal level directly with ERP. They correlate, but you'd be a hard time doing that.
Well, you're going to end up with some sort of coefficient in the front to scale the thing, because you're never going to see exactly what it is. And by the way, Hank, if you wanted to do the trick that you're talking about, you're probably going to have to get about a 40-foot pole and stick it up into where the field actually is at to even start to discuss the matter.
So
you're shooting over the heads of people with these stacked antennas. It's kind of like a lighthouse. You walk on the ground toward the lighthouse. The light isn't all that bright, but if you can get up in the main beam or a ship out at sea, it's pretty darn bright.
Wow, that's a great analogy.
yeah, that's a great analogy. And frankly, on these antennas that have high gain, not on a 4-bay collinear, but on a 16-bay television antenna or a 12-bay FM antenna, my last job was with an antenna manufacturer. We have to actually intentionally cause some spillage down toward the ground, so that people close to the transmitter side can actually pick up the station, because most of the signal is out plus or minus maybe 5 degrees of the horizon. So oftentimes we have to do either beam tilt to tilt the beam down a little bit, or what we call null fill to fill in some of the stuff underneath the tower. So in the case of a 4-bay collinear, up 40 feet, there's not much on the ground there, that's for sure.
Well, even worse, we've got an internet link that's 4.85 gigahertz on a 2-foot dish. Speaking of a tight beam.
Yeah, it's pretty narrow.
Yeah, we had a heck of a time aiming the thing. It had to be aimed about 20 miles.
So let's keep moving, because there's a whole nother section here of things I want to talk about. But I would like to do an 80 meter or a 160 meter, just so you know a different kind of scenario.
Yeah, I'll do it.
Okay, call sign.
Yeah, KE8NN.
K.
Kilowatt Echo 8 November.
And by the way, there is at the bottom there's a print hall, or there's a print hall, so you can print this document. I would appreciate it if you didn't hit submit, because unfortunately that comes to my email and I really don't want it. I haven't figured out how to get rid of that yet. So just hit it print, you know. Okay, go ahead. What's the antenna?
Okay, it's a long wire.
Okay. All right.
Let's try this 3.590 megahertz.
So what's interesting is if you put the top of the band in, you're going to get the least amount of power, but the closest allowed distance. If you put the bottom of the band in, you get the long, you have to be further away from the antenna, but you get the most power as it works out, as these calculators work out. So a lot of times people just put the top of the band in and they call it good. So, or you can put the bottom, or you can put the middle of the band in. So
that's a good place to operate.
Yeah.
Iridian CW.
Okay. So it calculates, once you put the frequency in, it calculates you've got to be 39.6 feet away.
Whoa.
Okay. So what's your distance?
What's the distance that I really am away?
Yes, let's be honest. Like I said, don't worry. There's another way to do this.
Yeah, to the closest point of the actual antenna.
Yeah.
Right? Okay, since it's a random wire, it twists around a lot. 6 feet.
6 feet. So this exemption is not going to apply to you. There's no reason to go any further. It doesn't apply. So
at this point, I'm still okay?
you're still okay.
Uh-huh.
You're okay.
Oh, hold it now. My transmitter power is 90 watts though.
Doesn't matter.
Oh,
You do not meet that calculation of wavelength divided by 2 pi.
so at this point, I'm okay.
But you're still going to be okay because you can actually do it. You can do a evaluation.
Yeah.
Okay. But here's a case where it's not going to work for you to use the exemption.
Mm-hmm. And this will allow me an ERP of 740 watts.
No, none of that. It doesn't apply.
Oh,
I probably should blank that out, but the exemption doesn't apply because so you don't pass part 1.
Steve,
Yeah.
this is NA6MB. Maybe you should explain that the difference between an exemption means you don't have to do any further calculations versus the next thing you're going to get into.
That's exactly right. It's a good point. It's a good point. So let's go to that. Okay. Let's go to the RF exposure on the ARRL website, which once again, all the links are going to be available to you. And I think I'm going to make this a little bigger. See if I can zoom this out a little bit for you. Okay. So let's go back to that last 80 meters. So I'm going to suggest, for the purposes of this demonstration, you assume you have a lossless coax. Okay? That hurts you in the calculation, but I think you're going to see it doesn't matter. So what's your transmitter power?
90 watts.
90 watts. Okay. So we need to know the duty cycle of the mode. So are you doing CW? Are you doing sideband? Here are your options.
Well, I would say, let's just stick with conventional SSB.
Okay.
50%, yeah.
50%.
Yeah.
And it wants to know your transmit time versus your receive time. What's your transmit duty cycle?
Let's see, 5 minutes and received. Yeah, that sounds about right.
Mhm.
And I'm going to suggest to you that your long wire has an approximate 2 dBi gain.
Yeah.
Let's say,
I'd say 1.5 to 2, so that it does have some gain, yeah.
and I have a resource for you to look at on that. And your operating frequency again is
3.5 or 3.090.
okay.
Oh, I'm sorry, 3.590.
Yes, that's right. Okay, and we're going to include the effects of ground reflections. Okay.
Okay.
So we go down here and we calculate. And I need to explain this, and I didn't jump back to the PowerPoint, so we'll do this and we'll go back to the PowerPoint. So the FCC has indicated there are 2 kinds of environments. One is the controlled environment. And for purposes of amateur radio, the controlled environment includes the amateur operator and the amateur operator's family. Okay? They should be knowledgeable about what's going on. Then there's the uncontrolled environment, and that's the general public. Okay? So basically the results say that your power density allowed, the maximum allowed power density based on the calculations from OET 65 is 69 essentially. And your minimum safe distance essentially a little less than 1/2 foot for the controlled environment, and the maximum allowed power density for the uncontrolled environment for the public is about 14 milliwatts per centimeter squared, and the minimum safe distance is a little bit over 1/2 foot.
So don't touch the antenna, in other words.
Yeah, which is what I don't do.
Right.
But what you're seeing is the difference between the ultra-conservative formulas for the exemption versus actually doing a calculation.
Wow.
Let's go back to the PowerPoint a minute here and let me see get that started again. And I'm gonna forward this to where we're at. Oops. What happened there? Let me restart this. Yeah, there we go. Okay. So this is available on the ARRL site, and it shows the various gains in dBi. So your long wire, basically, they indicate is about 2 dBi, as we kind of guessed. So in terms of doing a routine evaluation, which if you can't pass the exemption, then you need to do a routine evaluation. There's actually a few ways to do it. One way is to model it. I should say one way is to measure it. And you can measure it. The meters are about $10,000 and they have to be calibrated on a regular basis. So most amateurs don't have access to a meter capable of measuring it. And you can do it through a lot of different modeling. Some of you might be familiar with NEC, you know, Easy NEC and those kind of modeling programs. And for things closer than 20 centimeters, it has to be SAR modeling. But this is this wonderful OET65 document that the FCC created in the 1980s. And they provide a formula for doing the power density. And this is the basis of that calculator I showed you on the ARRL website, which is actually a calculator that a different hand club did and the ARRL has adopted. So this is the exposure calculator that we just tried to use. And once again, this is the various antennas. If I were you, I would use the manufacturer's spec for an antenna. So before we go on to HTs, somebody has raised their hand, and I'd like to answer that question. Okay, let's see. I don't know if I can read that.
I didn't raise my hand, but I do have a question. It's Mike NA6MB.
Okay, all right.
So are these? So people have made these pages and calculators. Are those formulas behind those very complicated? I'd like to have one where I could enter all my antennas and where they are, distances and powers and all that, instead of entering them one at a time and every band for every antenna. I copy and paste a bunch of columns because the gains are similar or the distances are similar. Is there such a thing?
Well, the calculator I made, this particular calculator, I'll get to it back here. It just uses this information right here. Basically, the distance, the required distance, you can see at the bottom here is frequency divided by 2 pi. 2 pi. So that's the calculation for the distance, minimum distance required. And then the calculation for maximum ERP for the exemption these are the formulas, depending on the frequency. So you could use those to build your own calculator.
So it sounds like you could put those in a spreadsheet and drop in 15 different antennas and
You could.
get a number next to each one for the minimum distance allowed.
This is for the exemptions, though. I was talking about, because I think last time I did this back in whenever it first came out, I had to calculate each antenna and print out a page for each one, and I have that in a notebook somewhere or a spreadsheet with the results anyway.
Well, just following in terms of the exemption calculator, I also wound up researching the K1, K2 factors for all the coaxial transmission lines. So it gets a little more complicated once you have to also compute the transmission line attenuation or stuff like that. But you can certainly do it pretty easily. And you can probably even, you can do it pretty easily just from this information. As far as these other calculations, if it basically comes out of the OET 65 guide. And you can, I think if you go to the ARRL website for their RF exposure calculator, they reference the original website that the program came from. So you could follow that up if you want. That's about all I could tell you. I think by the time you try to recreate all of this, it might be easier just to copy and paste a bunch of antennas.
Question?
Yes. Go ahead.
Okay, sorry, I had to change computers. My audio was bad. I had my hand lifted up before. On HF systems, when using tuners, how do you evaluate the ERP? Because as you know, the antenna might not be very efficient. It's very hard to measure. So what's the process behind it when you want to find out what using a tuner on HF?
Oh, I'll tell you, you've opened all sorts of a can of worms. To be honest with you, the limits are so high that, as you saw on that 40 meter or that 80 meter calculation, I just went ahead, I ignored the transmission line loss. I considered no tuner loss, no transmission line loss. I just used that as the antenna input power.
Okay.
So technically, you're right. One way to handle that would be to put a power meter after the antenna tuner and see how
it's not 50 ohms. You know, you don't know what the impedance is going to be. That's fine. That's one of the questions I've had, and other people have asked me also, especially when you're using a tuner inside the home. If it's near the antenna itself, you can measure it. But we both know that tuners are inefficient, and on some frequencies, your ERP might be much lower. So you just say use the power output in that case, and just forget whatever is happening. Okay, that's fine.
The ARRL has a program that comes with either the antenna book or the handbook, which is actually gives you tuner loss.
Okay.
And because believe me, when you're matching like a long wire or something with the tuner, you got plenty of loss.
Yeah.
It's not very efficient. So.
Okay, thank you.
I have a question also.
Yes, sir.
On the exemption calculator, I'm following exactly what you're talking about. If you put in those few items, what kind of an antenna and whatever, it'll tell you if you're exempt. Where do we find that calculator?
Oh, the calculator?
Yeah.
I'll show it to you at the end. I've got all the links.
Okay, good, thank you.
And your hand club would be welcome to put the link up on your website. As a matter of fact, all of this is on the Desert Rats ham club website, which is my local club. You can copy and paste all this stuff to yours and make that available also.
Steve got another comment, Mike NA6MB. Would it be fair to say that you could ignore the coax as you did, could ignore the tuner, could ignore all that stuff because it only makes it better for you? And you only need to worry about it if you're very close to not passing the limits. And just
Exactly right. It makes it worst case. But if you still, if essentially you say the coax is unity A, no loss, and it tells, so the calculator calculates what your ERP is, but the maximum ERP has nothing to do with your coax. The maximum ERP is based only on the distance from the antenna and the frequency and the gain of the antenna. So actually, it may not even be based on the gain of the antenna. So it's based on the distance, I think. So, but you're right, you can just ignore that stuff. And then if you're close, figure out what the attenuation is. All right, I'm feeling like I've been bouncing around a little bit like this, but hopefully I'm addressing everybody's questions. Why don't we push on to what's going on with amateur radio HTs?
Yes, do the HTs.
Okay.
Another can of worms.
Well, it turns out that the commercial operators of handhelds have had to do SAR testing for a long time. And from what we understand is amateur HTs haven't been SAR tested, but they're basically the same as the other HTs out there. And the feeling is the manufacturers will simply do the testing. And when you buy an HT, you'll have that issue addressed. However, the one thing you have to realize is it's SAR tested with a specific antenna. So it's not, you can't really buy an HT anymore and put a new antenna on it and expect it to meet the SAR testing, unless the manufacturers made a provision for that. The sweet thing about this is that any existing HT that was manufactured before May 3rd, it's grandfathered in. Doesn't have to be SAR tested. You can use it with any antenna. It's just the new stuff you buy. And by the way, I should mention that these rules are essentially to be implemented by May 3rd of 2023. So existing stations don't have to do any of this stuff until 2 years from now almost. New stations have to meet these rules immediately.
So let me ask this. You mentioned 2 meters, or 2 meters and 70 centimeters. What you're saying, if I understood it, is if I have radios here and I change the antenna, it's an issue. In other words, if I put a higher gain, whatever it is, so that's going to kill the market for these antennas. I'm just trying to understand it. I understand you're right. If you change the antenna, it's all bets are off.
Well, not on an existing radio, but any new radio you buy after May 3rd, it's got to be SAR tested with the antenna. So if the manufacturer provides the SAR testing with a variety of antennas, you're fine. But basically the radio is sold with an antenna. If it's sold with an integral antenna, and I think it will have to be, it's been tested with that antenna. And if you change that antenna to something else, you don't have a radio that's been tested anymore in compliance anymore.
I think one of the factors here is that with a longer antenna, the power density, the SAR, is going to go down. So it's those really short antennas like a stubby duck where you can get a lot of power density very close to the antenna. You got to kind of beware of those. And the same thing also applies to small microwave dishes. You can get a lot of power density close to them and not so for the large dishes. And of course, the far field doesn't really come into being until you get quite a distance from a large diameter dish. So you're all near field effect, which is probably a little too technical, but I think that the rule here, the conversation here, Steve, if you would agree with this, would be that, you know, you put a long antenna on an HT and you're not going to have to worry so much about head exposure.
I think that's the case, but I'm just talking about regulations to some extent.
Right, right.
The longer antennas are going to be potentially non-compliant. It'll be interesting to see what the manufacturers do with this, whether or not they're able to basically certify their device with different antennas. So there's nothing to worry about at the moment, except a new radio really should be used with whatever antenna it's supplied with. So what about cars? Because cars now are not categorically exempt anymore.
What about 70 centimeters? Has it changed from the point? Is it the same calculation you did before for 70 centimeters?
It's the same calculation, and actually, is it the same calculation? Let's see what that, we had to go all the way back here, but just bear with me a second here. Let's see. So you can see that the formula for 2 meters is 3.83.
Wow.
Distance squared, basically, where in on 70 centimeters we have a different formula. But
lower, yeah.
The concept is basically the same. It's got to be SAR tested because it's within 20 centimeters of any human tissue. So let's go on here. So what about cars? So I calculated what was going on with my car. It's on the right on VHF with a, this was a dual band antenna, 40 watts TPO and 12 feet of RGU8. An FM duty cycle of FM would be 100% duty, and the mode duty cycle and the transmit duty cycle was 2 minutes on, 2 minutes off. You can see the controlled environment for me or anyone in my family. I have to stay at 1.9 feet from the antenna on the uncontrolled environment. For anybody not related to me, they need to be at least 4.2, 4.3 feet from the antenna. And on the left, you can see the use of this, the ARR RF exposure calculator to determine this. Interestingly enough, we had a RF hazard meter we used to determine how much RF was in the car, basically, and the steel roof of the car is the ground plane. There was no measurable RF in the car from an antenna on the roof.
Unless you're sitting in a car with a glass roof.
Yeah, good point.
Mm-hmm. Well, could I clarify quickly then? If you're talking about the HF, excuse me, if you're talking about the HT and it's 2 centimeters from your head, you're still within the limits of the radiation because it just doesn't apply even to the level of the exemption?
Anything closer than 20 centimeters has to be tested through this SAR process. So there's nothing we can do on that. That has to be done by the manufacturer because it has to be modeled or tested by the manufacturer. It requires an environment to do that, which we don't have access to. So,
so you're saying therefore that they would have tested it on the SAR testing and therefore it is safe?
Yes, that's correct. And they've been doing SAR testing for a long time, the commercial HDs. So I don't think there's any anticipation that a 4-watt HT, a 5-watt HT is going to be any issue whatsoever.
Okay, thanks.
Okay.
Now, I noticed you had a completely different set of equations for 70 centimeter, and the calculations that you're showing there are 2 meter.
Yes. So here's
So,
here's 70 centimeters. But remember, I showed you the calculations for the exemption. If we tried to do this with the exemption, it wouldn't work. Won't work. You could run maybe if we go back to the exemption calculator, you can't make it work. So your only choice is to use the exposure calculator for mobile. Good question.
got it.
That's a good question. So, but here's what's going on with 70 centimeters. The difference is the antenna gain, to be honest with you. If you look, the antenna gain here in DVI is 4.1. So you see, what's interesting, actually, the safe distance is a little bit less, even with more antenna gain. But there is, I think, a greater loss. Actually, ERP might be a little less because the TPO on my radio is lower and the loss on the RG58 is greater. I don't want to be confusing everybody, but basically this all can be worked out in a couple hours, maybe at the most, for most people, an hour for most people. The idea is you create this documentation, you just keep it. You don't have to submit it to anybody, but have this. And frankly, I see this as part of the learning a bit of the craft of amateur radio, to be knowledgeable about what's going on in our hazard.
On your diagram there of the car, it doesn't mean that it's illegal or anything if somebody gets within that circle. You just don't transmit when they're in that circle, correct?
Absolutely. Absolutely. That's, as a matter of fact, we'll talk about how you mitigate. If you know you got to keep people 4.5 feet away from your car to basically maintain that uncontrolled environment safety zone, you don't transmit. Or to be honest with you, you make a really short transmission and say, stand by, I've got to ask somebody to move away from my antenna. Because remember, when you do the RF exposure calculation, the longer you transmit, the more it counts. So if you do a short, brief transmission of somebody who's within that uncontrolled environment, you can do that. You could just say, stand by, I'm gonna move away from this person who's next to my antenna.
A quick comment. It's interesting that the people that are screaming and yelling about HF radio transmitter in their neighborhood 3 houses away are calling on cell phones at 900 megahertz or 2.4 gigahertz, which are the frequencies of microwave ovens.
Well, that's exactly right. That's where the public doesn't really understand this very much. So if we go to the next steps.
For you on the topic of vehicles and keeping people away. I used to work for a wireless company, and they were changing out their phone number changed for their yellow signs that say, you know, RF exposure warning, blah, 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 please contact, and they had a phone number at the bottom. Their phone number changed for that, so they had to replace all the signs. They couldn't just put a sticker over it. They had to replace all the signs. So I got several of the old ones, and I'm planning on putting them on the back of my Jeep next to my HF antennas, just for amusement's sake. I've had them for years. I haven't done it yet, but I may do that now.
What number are you going to use?
I'm not going to put a number on there.
Well, if anybody's done an RF assessment, it's probably Bob Gonson. So he might not need to do anything at this point on this. But for most of us that have been operating under a categorical exclusion, we're going to need to do something. So that 20 centimeters is 7.87 or closer to your body. That for any transmitters like that, expect to see something about SAR, new transmitters, handheld transmitters. Remember that they'll be tested with a particular antenna, but existing HTs are excluded. And there's a 2-year transition period for existing stations.
But HTs are probably the most problematic, right? In terms of being most likely to exceed the SAR limits.
No, I'm not qualified to speak about that, to be honest with you.
Well,
but if you go back, I don't know. Well, you know, HTs are pretty low powered.
well, I don't know. 5 watts compared to a cell phone is actually quite a lot, and it is close to the head. I'm not saying it's hazardous, but I'm saying in terms of the limits. Also, the limits are the lowest in the VHF range.
Remember, duty cycle really factors.
Oh, and duties. Well, okay, yeah, duty cycle aside, but yeah,
Factors in, and that's a big part of this. That how much tissue heating can you
right
in such a little
Well,
period.
if this is based on the usage of our repeaters, it's on 1 minute, off for several days.
Well, yeah, that's true.
Nobody's running the repeaters anymore.
Yeah. I'm not saying it will be a problem. It's saying it's the situation most likely to approach the limits.
I can't.
Yeah, and actually, if you look at the radiated energy coming out of those coiled little rubber ducts on the HTs, they tend to radiate most of the energy relatively close to the connector on the bottom.
Yeah.
So,
right in front of your
has got
face.
to be the worst place for it.
On heat, basically. So yeah. And from a duty cycle, I think it's a 30-minute. It's either 6-minute or 30-minute. I think it's 30-minute. So they evaluate duty cycle in like 30 minutes, basically. So if you're on 5 minutes out of 30 minutes, you know, you've got a really low duty cycle. So
Another question, if I could. We're talking about now just HF stations. If you have, for example, I have a G5 RV. I use it from 80 meters to 10 meters. I imagine if I'm looking for an exemption, I could look at the worst case. So would that be at the 80-meter end or the 10-meter end?
well, what works is you'll have to remain the furthest away for the 80-meter end.
Okay,
But
so if then I test it and I'm exempt at 80 meters, I'm done.
well, that establishes the distance, the minimum distance. The maximum power will be least at 10 meters. So if you evaluate it 80 meters, and you can just use that table. I'll go back to that table in a minute. You can see what the minimum distance is for 80 meters, but evaluate it for 10 meters, because the 10 meters will give you the least amount of power. We can go back and do that in a minute.
Well, what about using the same power from 80 through 10?
Well, from the exemption, the maximum allowed ERP will be at 10 meters. So we'll go back and do that in a minute, just to demonstrate that, because it's a useful exercise.
Okay.
Just to wrap up, I've got 2 slides here. Regardless of anything else, we need to operate safely. And that means being aware of our RF level, RF emission levels, and remaining underneath the FCC thresholds. And your options to do this are move your antenna higher, put up barriers or signs to keep people away from your transmitting facility, transmit for shorter periods of time, lower your power. And we talked about pausing. Somebody walks up to the back of your car where you have a trunk mounted antenna, you know, do a short transmission until you can clear the area.
Okay, when you say mount your antennas higher, the logic there is not that you're getting out of the radiated field, it's just that you're increasing the distance.
Yeah, get the antennas away. Get the antennas away.
Bummer.
So,
It'd be nice if they took into account the pattern of the antenna.
well, you could do that, but then you have to model the antenna with something.
Back to good old Easy Neck. I got to find my license.
There you go. You can accomplish all of this by modeling antenna, looking at the vertical pattern, the horizontal pattern, and determine what the field is. But if you don't do that, then the FCC says use the maximum gain of the antenna.
Oh God, I haven't used that in years.
Okay, but you could do that.
That would be a fallback. If you have issues using the formulas, you could go and try to tweak it with the fallback. But in reality, if the formulas work, why even go and run Easy Neck to find out? Yeah, I agree.
Absolutely. It's really a
because we're hams and
I
we
know.
mess with everything.
I know.
The 3 steps are check the exemption. If the exemption works and you can get enough power, you're done. Just print it, you're done. If not, then go ahead and go to the ARRL website and calculate. And these are the links that are really useful. This is available on the desertrats.us website. If you want to make these available on your website, you're welcome to do it. But these are, there's some great instructions on this third link. The exposure calc instructions are great to answer a lot of questions. And then the 4th link is the RF exposure calculator. And then there's other useful information for people who want to read the OET 65 supplement B. It's available. Do I have time? Can we go back to the exemption calculator for a minute, just to try out a couple things?
Like we can.
Officially, there's the meeting ends at around 9 o'clock. However, pretty much everybody ends up being pretty hardcore. And I've had to close it down at 11:30 because I was just getting tired. So I'd say go for it. Have fun.
All right, well, let's go back to that question about the G4RB.
Right.
Okay, what's your call sign?
K2RP.
K2R.
P like Peter.
I'm sorry, say again?
P like pizza.
Oh, gosh, say it phonetically again for me.
Kilo 2, Romeo Papa.
Oh, okay, thank you. Whoops. Okay, and it's a G5RV? I forget. G5. And this isn't required, but it just allows you to know what you put in there. So so let's go ahead on let's put 3.5 megahertz in. It calculates the minimum distance is 44.7 feet. Okay.
Okay.
All right. So now let's enter. What's your distance?
Distance to the antenna?
Yeah, any part of the antenna.
Oh, maybe 25 feet.
Okay. So obviously this is not going to work. Exemption does not apply.
Okay.
All right. But let's say you had 45 feet. Friends, let's just do that. 45. Come on here.
Next line.
Next line.
Down.
Oh, I'm sorry. Yeah, thank you. Okay. 45. All right, exception applies. What kind of coax do you have?
RG 58.
58. Okay.
Oh my.
Okay.
It's probably got probably have 50 feet.
Okay, 50 feet. Okay. What's your transmitter power?
Usually 200. 200.
Okay. And oh my gosh, I wonder what the G5RB is.
Well, it said 1.0 on that chart that you had before.
So that was 1.0 DVD. Okay.
Dipole, yeah.
Okay. So essentially, Your effective radiated power is 233 watts. We've calculated that for you. And you would be allowed, in terms of it from an exemption perspective, 53,000 watts.
How many watts?
53,000.
Oh, so if I change that to 600 watts,
You can change your transmitter power to 600 watts. Your RG58 isn't going to want that. Let's go ahead and let's change 600 watts, and let's put some RG8X in there.
no, I actually do use 58. So,
But at 600 watts?
yeah.
Okay.
Not at 600, you
A
don't.
lot of loss there, yeah.
Oh, baby. Okay. Well, you've got 698 watts of ERP. The maximum ERP doesn't change because that doesn't have anything to do with this. You know?
Okay, so would if I printed this out and put it in a station log or something, would that cover me up to 10 meters?
No.
I
They
do
cut
meters one now.
for 80 meters.
Well, wait, one thing though, we're on 45 feet. What if we put that back to 27 feet?
You can't use this.
Oh, then I'll have to go through.
Yeah, but let's work the other end though. Let's pretend you got 45 feet.
Right.
Now let's put in, do you want to put 14 megahertz, or what do you want to put in for 10 meters?
We'll put in 28.
28 megahertz. Okay.
While you're in the process of doing this, can I ask you a quick question?
Sure.
For things like repeaters that are on a single frequency, this is trivial because you know the frequency all the time. If you're working bands, I gather that what you have to do is run this calculator for each band. But then it comes, being the technical part of it, do you have to run it for the top, like when you're doing part 15, if the band is over a certain width, you got to do a test at the bottom of the band and the top of the band. And if the band is a certain width, then you got to run it at the middle of the band. So how bad is it?
To be honest with you, the way the formulas work is that you have to have the maximum distance at the lower end of the band, and you're given the least amount of ERP at the upper end of the band. And to take that to the extreme, look at this situation. We've gone to 28 megahertz. We're allowed, at 28 megahertz, we calculate with that RG58, we're generating an ERP of 599, but we're still allowed 828. So,
but you've got 45 feet in there.
that's okay, but my point is this: at 3.5 megahertz, you're allowed 53,000 watts.
Yeah, but the worst case is the 28 for me.
At 28 megahertz, you're allowed 828.
But I'm only running 600, so it doesn't matter.
So you're fine.
I'm not fine because I don't have 45 feet.
That's true. But what I'm saying is, if you have a multi-band antenna, and if the gain is essentially the same on every band, or if you decide you take the maximum gain for all the bands, and if you run this at the lowest band, the lowest frequency, and you pass, and you run it the highest band and the highest frequency, you will pass at all the intermediary bands and frequencies.
Yeah, but my limiting factor is my distance of 25 feet.
Well, let's try one other thing here. Let's go to 7 meters, okay? 7 megahertz, and let's go to 25 feet. Whoops, 25 feet.
So then I'm okay.
You're okay. So what you have to do, what I'd suggest is do the exemption for 40 through 10 meters.
10, yeah.
And do a 40 meter and a 10 meter exemption, and just do an evaluation for 80 meters.
Right, okay.
You're-
And once you do all these things to be compliant after 2023, you just need to make a copy of all this stuff and,
You do it with the station log,
yeah,
that's all.
yeah, that to me, I'm more of a practical person than a theoretical person. I just need to know what to do.
So for Ron, for 80 meters, he'd have to do the calculation and then he'd have to lower his power because his distance is not big enough, probably, right?
That's right. I mean, if he wants to just use the exemption, he would have to. He can on 80 meters because he doesn't have enough distance. He doesn't meet the wavelength divided by 2 pi.
No, I understand. I understand it 100%.
So but he does on all the others. And you're in exactly the same situation I am in, where my horizontal wire antenna, I'm 25 feet away, so I will do exactly what we just did. And I'll just calculate it using the hazard calculator for 80 meters.
Actually, it might be even further out to measure. But the bottom half of this just tells you how much power you're allowed to run.
That's right.
Okay.
And it's kind of cool. You see what your ERP is. So you know what your ERP is in the direction of the antenna that has the most gain.
It's interesting. It says that the gain is 1, but I got more ERP than I do power. I'm not sure how that works without it.
Yeah.
Look at
DBD.
Right. So your transmitter, you have 1 dBd gain.
Oh, okay. So if that was 0, if the gain was 0.
Yeah.
Then,
Let's go to
give you. I don't know if they'll let you do that. Well, yeah.
So there you basically have essentially, you see what the loss is on your.
Yeah, that's a lot. Yeah, if we use the bigger coax, it would be a little higher power.
Use RGA. Well, it's a little better. If we use LMR 400, it's a little better.
Yeah, but it doesn't, you talk about all that loss, you're changing, ERP changes by 30 watts.
Yeah.
It doesn't, that's not much loss.
Well, at 7, but let's go to 28, okay? I think it's a little different. Well, it's even not that bad at 28. Oh, on RGA, on G58. Yeah, now you got your coaxes can get hot.
Yeah, well, I don't think there's a person that can tell the difference between a signal of 500 watts or 600 watts. It's a fraction of a dB at the receiver.
Steve, I have to leave the meeting early tonight, right now, but this has been a great presentation and my first exposure to these calculations for amateur radio. I'd like to follow up on the phone with you just a little bit, if I may. And do you have a phone number where I can reach you and a good time to call?
You can call me hardly anytime. My phone number is 619-347-4306. And the easiest way to get hold of me would just send an email to KA6UGS@ARRL.org. But I'd be happy to talk to anybody about this if you have some issues or questions. I'm learning as I'm going along, although I dealt with this on the broadcast side of things for years. But and there's a wonderful QST article, most recent QST.
This one, yeah. But Steve, I want to compliment you for making this understandable to somebody who is really very non-technical with this stuff, even after all these years. And I really understand far better than any magazine article. So I thank you. You've done a great service tonight.
Thank you. It's interesting. People have been close to me along the line. I can tell you that. So.
Yeah, thank you very much, Steve. And I'm sorry I have to leave early, but I will drop you an email and continue on for a question or two. And again, thanks. Great presentation.
Just a note on that email. I believe the call sign emails are at arrl.net, not .org.
Thank you.
I believe.
Oh, I'm so glad you corrected me on that. Thank you.
Because ARRL.org are the email addresses for the people that actually work there.
I'm curious, can I get you to run one more calculation before you run away?
Okay.
Yeah. Give me a call sign.
All right, but good thing Charlie's not here. KF6WTN.
KF6.
Whiskey Tango November.
Okay. What do you want to, how do you want to designate this antenna?
It's DB-18.
Okay. All right.
Let's stay at the 28 megahertz for the moment.
All right. So this calculates, once you put this in, it calculates 5.6 minimum distance required. And what's your distance?
I calculated it to be 85 feet.
Okay. All right. Exemption applies. You want to give me a coax?
Yeah, it's LMR 400.
Okay. And length?
120 feet.
Transmitter power?
1500 watts.
Okay. Antenna gain?
Let me see. At that frequency, it's 9 dBi.
Oops.
Got a power boom.
Yeah, power down.
Well, what it means is you have to go to the ARRL. Shall we do that on the ARRL? Let's just do it. 1500 watts.
Yep.
Oh, what's the mode?
Probably single sideband, 50% enhanced duty cycle.
Okay. And what's your transmit duty cycle?
I'm kind of quiet. Let's go for 1 minute on, 3 minutes off.
Steve, you never talked for less than a minute your whole life.
Now, what did you say the antenna gain in dBi was?
At that frequency, it's 9.
9, okay. And 28.
Yeah, okay, for the people who know me, you better make it 2 minutes, I guess.
2 minutes on. Okay. All right.
2 minutes on, how many minutes off? 3 minutes off?
Sure,
That's a
you
high
gotta let
duty
the other
cycle.
guys talk.
Are people going to vote on that? I'm not. All right.
Yeah, do you guys want to take a vote?
So let's calculate. Wow. Interesting. Minimum safe distance, 23, almost 24 feet for the controlled environment and almost 48 feet for the uncontrolled environment. What's working against us on this is higher frequency and also the fact you're running a lot of ERP.
Yeah, higher.
Yeah.
A lot of power. But you'll always get a better deal with this than the exemption calculator.
Interesting. Thank you. Hey, that was under 1 minute, guys.
It just as an interesting comment, the equations that you have work both ways. I used to work in FCC Part 15 devices where I measured fields radiating from the devices. And there was a real interesting article about jet aircraft at the end of a runway in Florida that were dropping their bombs because the ERP from the radar set was so high that the squibs were firing that released the bombs
my.
underneath the aircraft.
Mhm.
And
Yeah, I had that. I had
well,
that problem on an F-16 in Fort Worth, but it was screwing up the data communications line between the smart bomb and the computer.
Now, from what I remember, this was a number of years ago before I retired, but they had some kind of over-the-horizon radar in Florida that was transmitting such a powerful signal that they were radiating more than 200 volts per meter, which was what the squibs were rated for. Wow. And when you calculate it backwards using your same formulas, it comes out to be like 5 million watts of ERP or something like that when they were, and they couldn't do anything about it because that's the only place they could put this radar, where it was on southern approaches to the United States.
Whoops. Well, fortunately, the stuff that I did with squibs in it is all EMP red hard. So the squibs are all embedded inside of blocks of aluminum and things. So they're not going to get any energy, thank goodness. But the F-16 was rather thrilling that day. Fortunately, it was all dummy ordnance.
Well, from what I remember, what I remember of this, the aircraft as they were coming into the end of the runway, the pilots were, or they were less than happy with the pilots because they thought the pilots were discarding their munitions. And the pilot said, "I didn't touch a thing." And long story short, they now turn the radar off so that whenever the planes are taking off or landing.
Yeah, you call that increased pucker factor.
Well, thank you, Steve.
Shades of the story of Gus Grissom. Remember on his flight blowing the hatch prematurely? Remember that story? Well, the recent discovery apparently is that it was an EMI discharge from the helicopter. It was trying to rescue him. Blew the squibs on his hatch. That was just recent news. After 60 years, something like that. Yeah, this stuff can be very subtle.
Well, I'm going to kind of say 73 at this point, I think, and don't hesitate to contact me.
Yeah. Thank you very much, Steve. That was a fantastic presentation. Had a lot of engaged comments and questions. Really, really impressed. This was fantastic. Thank you so much for joining us.
Putting it on our website, right, Joe?
Yep. I already had one person email me ahead of time and said, "Hey, I really am interested in this presentation, but I can't make it tonight. Can I get the recording?" And yes, I've already sent them the link to the recording, and it will be up on our website. And Steve, if there's any links specifically that you want me to include in the post, just reply back to that email and I'll add it to the website and to the YouTube description.
All right, good. Well,
all right. Well, with that, it's 9:24. We'll close this meeting. Thank you all. Again, the October meeting is scheduled to be the auction, hopefully in person. Look for more information in your email.